Welcome everybody to Six Sigma Green Belt lesson number 25. If you look at the table of contents, under that, if you look at section number 3, which is Lean and DFSS, which stands for Lean and Design for Six Sigma, and Lean Principles and Concepts, under that section, we'll be covering these three areas today. So the reference material for these three will be attached to the video, and you can visit our website to see that reference material. So moving forward, we'll start with value flow. So talking about value flow. In a traditional mass production environment or company, generally follows a batch process. And this is still happening today. So what happens is, in this type of company, main objective is to make as much as you can that can be made, and the main idea behind that is so that overall the efficiency of the production goes up, and this is done to improve efficiency of the plant. So unknowingly, the optimization may lead unknowingly optimization may lead to sub-optimization of a process, and that is not good. But for lean, we require the conversion of a batch to a one-piece flow. And when you have that one-piece flow, this one-piece flow is an ideal situation. And this is an ideal situation that every company should aim for. So moving forward, whenever we go through this transition, this change process from batch to lean, go through this change process, following challenges appear. One is we have always been and done this in batch or in batches. The second is we live in a world of departments and functions. And third is this is a lot based plant. Number 4 is we don't have quick changeover techniques or methods. Or we don't have tooling or equipment to support it. Number 5 is we have high momentum machinery that is not flexible and suited for lean. So normally these are the kind of things you'll hear, but we have to overcome these because the benefits of lean, they are just unbelievable. You just have to see it, implement it, and see the results that it'll bring to your corporation. So in lean world, you see production cells or areas are generally U-shaped. So process goes from one side and it ends on the other side. An example is, you can see a cell like this. So the process enters from this side, goes this way, goes this way, goes this way, and then finally you make your product. So normally you'll see that in a lean environment. In relation to that, continuous flow layout, and when a company has this continuous flow layout, the production steps for one or single piece flow are arranged in sequence in a straight line and WIP is kept to a minimum. So basically, to summarize this slide, in a continuous flow layout, the production steps for one piece flow are arranged in sequence or in a straight line, and WIP is kept to a minimum. When we have this concept in place, this type of concept in place, it's expected that the work at each station and work done by the operator should meet reliability requirements. In other words, it should be reliable. A note is, when equipment is performing as expected, company faces So they'll face 1, 0 breakdowns of the equipment. You'll see the quality of the products go up. So to have machinery or to keep machinery performing as expected, and have less breakdowns, a company should have the following systems in place. Systems in place, and they are very critical, and there are two. One is TPM, which is mainly done by the operators, and the other one is PM. PM stands for preventive maintenance, and TPM is total productive maintenance. And this is done by the operators, and this is mainly done by the maintenance team. You gotta look at it that way. If you're driving a car and you change oil as required every 3,000 miles or every 3 months or 4 months, and you do your tune up and everything, the car is going to perform better as compared to if you don't do anything. If you don't change oil or do tune up or do other activities as required, that car will eventually break down. So that's a good example for this. So moving forward, quality level when you have this TPM and PM system in place, the quality level of each operation is close to perfection. And let me make a point here. It's just not because of the TPM and PM, it's also because of the lean principles that you have in place, which results in a high quality level, and that then changes to perfection. So quality level of each operation is close to perfection by implementing following items, which are defect and detection techniques. Everybody heard about Poka-yoke, and that is error-proof method. So a company can implement a Poka-yoke to prevent defects from proceeding to the next step. Second is source inspection. And this is to catch errors. So to catch errors and correct the process as needed. The other one is self-checks. And this is checks performed by operators and correct the issue if needed. The other one is successive checks. And what this is, checks done by next process and to correct the process. So if we have these four things in place, you'll see the quality level of your product or process go up. And these are good systems to have in place. So we'll continue with value flow, and the activities needed for a good or excellent production should be the following. 1. Steady pace or steady. Second is have a continuous flow. Keep on moving the material. Don't let the material sit down for a long period of times. Number 3 is no wasted motions. Number 4 is no batches. Number 5 is no minimum width. And last is flexibility to meet your business or present needs. So you need some kind of flexibility there. To make value stream or value chain flows smoothly, following adjustments may be required from the work of people the work of functions and the work of departments, and then the firm by itself. So we'll move to the pull value. We'll spend time talking about this. So what is pull system? In this, instead of making products in response to a sales forecast or whatever forecast you have in place. The plant makes products as the customer requires it. So this is pull. This is a pull system. So instead of making products in response to a forecast or any other system you have in place, you make products when the customer wants it, not before that. So this is a pull system. And this pull system has many positive benefits when implemented in a right way. Do it right the first time. So there are positive benefits when this is implemented, and to name a few of these benefits, what happens is you'll see a decrease in cycle time. Second is you'll see decrease in time from a concept to launch of a product. You'll see increase in on-time deliveries, and that is to the customer. You'll see the conversion of raw material to finished goods quickly. So the material doesn't sit in the factory or in a plant for too long. Also, the inventory levels are reduced significantly. And the other one is WIP is also reduced, and WIP stands for work in process inventory. The other one is the customer starts to stabilize their ordering process. So customer stabilizes their ordering. And pricing is stabilized. So these are some of the benefits when you implement a pull system in place. Even nowadays, most mass production companies are still in the push system. So each operation in that kind of environment, each operation will produce as much possible and then push down everything to the next operation. And this is mainly done to keep a high efficiency rate. So when you do this, so this is mainly done to keep efficiency, which is the production efficiency, high. And then you also generate tons of WIP that you may not need eventually. So compare this to a factory that has a pull system. So now think about a factory that has pull system in place. When you have that, here the receipt of the customer order initiates all the activities, and that is your production activities. So here the receipt of the customer order initiates all the production activities. Each operation in this upstream produces parts as they get signals from downstream operations. So you don't make anything in advance and push. So you only make when there's a signal from the downstream process or the operation. So due to this, minimal amount of WIP is produced. And everybody knows WIP equals dollars. So that's a lot of dollars sitting. So when you implement this pull system, you reduce this. So the width is reduced. So this creates a continuous flow through the entire plant using lean principles or lean methodology. When you put this pull system in place, when you implement pull system, you'll see the following issues come up and they'll magnify. Which is good. You want to see these issues. Some more related to quality, machinery, downtime, and absenteeism, which every company faces this. So when you have pull system, these issues will magnify and they'll come up. So it's good that these show up, because it means that a company has opportunities to solve. So it's good to see that when these show up, and it means that opportunities exist to solve, and eventually will end up satisfying or delighting our customer, which is the main goal. So that is it for today's lesson. Thanks for your participation, and please check the reference material that is attached to this video for your review. Thank you. Thank you for your participation. Have a wonderful day.